Love to know. We're already an international audience today. So we do this every week. This is RockSim Live, where we talk about the RockSim software. My head is a little bit like this today because I had just come off another live stream for NARCON. And NARCON is the National Association of Rocketry annual conference. And it's a virtual conference this year, and I did a presentation on touring Apogee components. What is our history and what's it like here at the Apogee? You know, get the tour. That was awesome. It was. I had a 20-minute video which I'll post to YouTube probably next week, and then after that I answered questions for the last 45-50 minutes. It was a long time. There was just I didn't even get through them all. There was just so many questions about Apogee, and everybody wanted to know what we're working on and what's my favorite kit. And if you're interested in what my favorite kit is, the official answer, because it is the answer, is the next one. The rockets I've done in the past, I've been there, done that. Now I am interested in what's forward, and we've got 3 new kits coming out. We got the Habu, which is this one here. We got the Atomizer, which is about the same size, but this one has a ringtail. This one doesn't. That's kind of the difference. And then put this on its display stand. Come on. And then we got the Razzle Dazzle. So right now, these are my favorite rockets, and but they won't be my favorite for very much longer because it's time to start working on the next one. Okay, so let me share my screen so you can see what I'm seeing. So kind of a little background about RockSim. It's a software simulation for rockets, and we have a RockSim Live, and you'll see here on our homepage at apogeerockets.com this banner ad for our RockSim Live training, which you're here right now. But if you click on it, it will take you to our archives. And we're on episode number 54 today. Today is January 28th, 2022. In the archives, we have all the topics that we talked about previously. So if you want to know something about something specific, you can just come over here and type in what you do. Instead of scrolling through them all, you can do Command F if you're on Macintosh, or Control F if you're on Windows on your keyboard. And that will bring up a little menu up here at the top, and you can type in a word, and then it will find where that word is located on that page. And it's on this page 5 times. Here's the first one, clustering engines in RockSim. And then we have clustering revisited, inside tubes only, how to create a cluster design in RockSim. And then the last 2 are from January 29 of a year ago. Man, it's been almost a year ago. How do you make a cluster rocket in RockSim, and then how to make a template if you're doing clusters. So that's where RockSim Live comes in really handy. We also have videos on how to use RockSim. If you go to How To and Guides, click on that, come down here to Software, and then come over here to this column. We have the RockSim video tutorials. We have another link to the RockSim Live training, which I just showed you. And then there's RockSim Pro tutorials here as well. So there's lots of information on how to get started. So, wow, all of a sudden the questions have... Someone says I have no sound. I am seeing sound go out. Testing 1, 2. Let me figure out sound. I'm adjusting the sound here. Testing 1, 2, testing. See, this one shows external. It shows my audio and video are in sync. You have Johan de Sloper from the Netherlands here. Audio and video are not in sync. Okay, audio on. Okay, I'm having a heart attack there for not having audio. Sounds fine on my end, says Tony. Thank you, Tony, for that, letting me know. Where was I? Okay, so one of the new products that I just announced at Narcon that we're going to be releasing, you guys know about already, and that's the RockSim Launch Visualizer, and that is on our website, rocksim.com. So on your browser, you can go to rocksim.com, and this is the Launch Visualizer. It'll come up here in just a second. And we've seen this before if you've been coming here to these RockSim Live trainings. The official news is next week we're going to come out of beta and we're going to release it to everybody in the public. So to you that probably means nothing, because nothing is going to change from what you're seeing right now on the rocksim.com website. When you go here right now, you can use all the features, you can play around with it, but if you log in and if you create an account, see if you can, you can sign in, or you can create an account or create a new account right here at the bottom. When you create a new account, it takes about 30 seconds. All we ask for is your email name and your name and your email and a password so you can log in. Because once you log in, we assign you server storage space so that your simulations that you run will always be there. And all the stuff that you upload, your RockSim files and your designs, will be there. That's why we ask, to create a password so that only you have access. I don't have access to your password, and I don't have access to what's in your database. But next week, we're going to purge that database, and we're going to start fresh, because this is going to be the official release. So you can make an account today, but it's going to be purged, but then we're going to start it up again. So basically, you'll just make a new account. And again, it just takes 30 seconds. And the reason why we're doing that is because our beta testers and all the developers, the people that are writing this for me that I've contracted with, it's a whole team, and it's a whole company of people, and they have different people that are specialists in different areas of the software. So each of those people is making accounts, and they're making duplicate accounts, and they're doing credit card payment stuff, and making fake accounts and all that stuff, and we just got to clear all that trash out, and so then we'll have a clean database with just, we're assigning server space to those people, and we want to just get all that server space back so that we're not paying for server space for people that aren't going to really use it. So that's why we're going to clear it out. It's nothing nefarious. We just want to start clean. But in the meantime, you can make an account, but just remember, next week you're going to have to, when you go to log in, your account might not be there, and then you'll just be asked again to create a new account. So you can create a new account here. You can use your current Apogee account. If you ever bought anything from the ApogeeRockets.com website, you already have an Apogee account, and you can log in using that and the password that you use for that, or you can use your Facebook account or a Google account. So there's 4 ways to log in, create an account. Once you make an account, you always have to log in to your account using that method in the future. So if you decide to use your Google account, you will always have to come in and use Google to sign in. That's just what that means. Okay, so this will go live next week. And when we go live, that means if you want to use all the features, there's going to be a small fee. It's a monthly fee, and we're going to start out at $3 a month, because that's what I promised you. Due to inflation, it's not going to stay $3 for too long. So once you're in at that rate, you're in. So, you know, get in early. The other cool thing is if you go to the Apogee website, Apogee rockets, one of the things that I want to show you that we're doing is something really cool with the launch visualizer. Aerodactyl. I'm typing in the Aerodactyl kit page, and if you go to that kit page, on this kit page, people always ask us, what motors should I get? And in the past, we have these motor charts, and you can select your motors based off of what you see in the charts. These would be good things. But now with the launch visualizer, you can actually run your own simulations. See, these simulations here are based off of launch conditions that I specified. But if you are flying from your own field with different launch conditions, your motor selection is going to be different. So we're actually going to put a widget on this page, and on the Aerodactyl web page right now, the widget is there. This is going to be what it looks like. And you can see it's got a play button on it. And I'm going to click on that play button, and I'll start up the widget. And so you can see the screen changed, and it's loading the launch visualizer here on the Apogee website. And not only does it load it on the Apogee website, it also loads that particular rocket design. So here is the Aerodactyl design in the widget on the Apogee website. So then you can load your motors right here on the page, and you can say, oh, well, let me go down here to this and try this combination, look at like an F20-7. So then I would come up here and you know, choose engine. I'm not logged in, so this is one of the things I had to log in. So if I logged in, and if I logged in under me, so now I'm logged in from the Apogee website, and I can choose an engine. Now I can choose a 29 millimeter. Let me see what we want to go with. Aerotech motors. These are only showing 18 millimeter motors. Oh, okay. Let's show all engines right there. I'm looking for a 29. Okay, so I can choose an F67. Click OK. Interesting what that did there. What happened to my Aerodactyl? Let's try to launch it and see what happens. See if I get my Aerodactyl back. It's running the simulation in the background. Huh. I wonder if I had to tell the programmers that something's wrong. This is live right now. My widget is not working right because it should have been done by now. Let me refresh the page. See, if anything happens, you can just, you know, refresh the page, relaunch the widget. Should load the rocket on the pad. There's the rocket on the pad. And if I click up here, select motor, so now it's a two-stage rocket again. So and choose engine. There we go. Now I'm getting motors that I should be getting. Let's see. Where's the Estes motors? Cesaroni, Cesaroni, Cesaroni. There's a lot of Cesaroni motors. Sky Ripper. I'm going too far. Okay, here's an F15 from Estes. Click OK. I'm going to load that one into both motors. And, you know, this is a widget. So you got these scroll bars within a scroll bar. That's the one thing that, you know, if you're seeing black right here, that means you're looking at the rocket from underneath. Let me click the home button. There we go. So this is three-dimensional, so you can look at it. And then if I scroll back up to the top, I can find my launch button. There's the launch button. See, this launch button, it can kind of get hidden underneath these tables. See that? But it's right there at the top. So if you ever want to play with it, just click on it. And then simulate. And hopefully it's going to run this time. While we're doing that, I'll go to my questions, see who's got a question. Leon says, how can I buy from Bangladesh? Well, your question has probably be, how can I buy rocket motors in Bangladesh? And unfortunately, we don't sell rocket motors outside the United States. We can ship you everything else, but not rocket motors. So if you would like to buy, all you need is a credit card or PayPal. So here's the rocket sitting on the pad, and we can just run the simulation right from the Apogee website. So it's taking off, and this is just like the launch visualizer we've been talking about every week. You got these zoom buttons right here, so I'm zooming out, trying to get a better view of the trajectory here. There we go. Oh, now I'm zoomed out too much. Oh, you get the idea. It's very cool. So I want to get back to your questions over here, because that's what you're here for. We have Kevin's Models and More watching from Las Vegas. Awesome. Okay, so try out the launch visualizer. Try out my widget. The widget right now, we're going to put it on all the Apogee kits, but it's not on all of them yet. It's only on the ones that start with the letter A, like Avion, Apprentice, Amarok, Aerodactyl, Airmail. We're not up to the letter B yet. There's more A's than any other kit. So we'll get to all of those. I did have a question that came in that I'd like to answer. So somebody asked a question, how do I know what rocket motors to put in my rocket without going through trial and error like we were just playing with the launch visualizer? The way to do that is in RockSim or RockSim Pro. It has a feature that we built into it to allow you to do very fast pick rocket engines that will work in your design. And it's not going to be just one engine. It's going to be multiple engines, because most rockets can fly with multiple engines. We just want to sort it by what would fly safely. So first, let's open up a rocket design. So I'm in RockSim right now, and I will open up about Habu. Habu is this rocket right here. I'm going to click open, and Habu is, you're seeing it on the screen. This is what it looks like, and you can come over here to 3D, click here, you've got the 3D image of the rocket. This is also, you can spin it around, look at it from different angles, look at it from the bottom, whatever. But we want to find out as fast as possible what engines would safely fly this rocket. So the feature is you go up here to the prepare for launch. This is kind of like the bottom of the rocket with two arrows pointing down to the launch pad. So it's kind of like I'm putting my rocket on the launch pad. So click on that. That's prepare for launch. And then there's a button right here that says recommend motors. Just click that button. When you do, it's going to bring up a screen that says, okay, we're going to run simulations with all the motors in the RockSim database, and these are the launch conditions. Right now we're at 213 feet, or not feet, meters, which is about 700 feet. We have an 8-mile-an-hour wind speed. These are the conditions that I use when I run simulations. So it's kind of a typical day. You have some wind, and we want to make sure it's going to be flying safe with a little bit of wind. And we're going to one thing you have to change is the launch rod length. So this is a small rocket, so I'm going to say let's launch this off of a short launch rod, and the short launch rod is 3 feet, but you can come over here and you can change the length of the rod. You can see you make it longer, but a typical launch rod is about 3 feet for small ones. Mid power is about 5 feet, and high power is 8 feet. The only time you have something that's longer is something that's like even bigger in diameter. You know, a big rocket that might be 8 inches in diameter. You might want a 20-foot launch rail or tower. So if you're launching that, then you would adjust that. And then the only thing you need to do is click on the button that says use recommended conditions. Just click on it. And what RockSim is going to do is it's going to run a simulation of all the motors that fit in that rocket. And there's 30 of them that fit. And it found of the 30, it liked 20 of them, the initial conditions. And so it's rerunning 20 new motors. The second time it runs through what it's doing right now, it's finding the optimal delay. What's the best delay for the parachute to open at? So that's what it's doing right now. And then what it does is it comes back to this screen and it shows you all the motors that it just ran. You can see the recommended motor tab right here. Every time you run recommended motors, it's going to clear out this data and then repopulate it. So here are the motors that it ran. And these columns, you can click on them. So if you click on the one that says RockSim's recommend, click on that, and it will, if you do a right click, so with your mouse, use the right mouse button, click on it, and say, I have it set at show only recommended motors. But if I click that again to show all motors, now you can see this column has recommended and not recommended. So it doesn't like this Quest B4 motor, but it does like the Aerotech C3 motor. And the reason it didn't like the Quest B4 motor was because it felt that the liftoff speed coming off the launch rod, off of a 3-foot launch rod, was too slow. Maybe you extended that to 5 feet and you rerun it with 5 feet. I bet you that B4 would probably work. Because what it's looking for is speed coming off the launch rod is sufficient so that the fins will produce lift and drag in order to stabilize the rocket. So if the rocket is not flying fast enough coming off the launch pad, it's going to say unsafe. And then you have other criteria that it looks at for whether or not the rocket is safe. This one is 90-degree safety. That means that the rocket throughout the entire flight never went like this. Never went horizontal, which is good, you know, because sometimes, and I've seen this where a rocket goes up, does a loop, and then goes off straight. Well, it may reach a nice altitude, but if it does a loop, that's not good. So we wanted to catch that. So that's why that's built in there. We have a static margin of safety right here. That's to make sure that as the rocket is burning off propellant, that the center of pressure is always behind the center of gravity. So that's what static margin safety means. And then the last column says safe deployment. Does the rocket deploy its parachute at a safe speed? And some of these, like the Quest A3, remember when it ran those simulations twice. The first time it was finding out the first time it was really looking at liftoff speed. The second time it's looking at deployment speed. You know, what's the best deployment speed? So this one right here, this Quest B4, because you see an NA here, it didn't rerun that simulation the second time. That's what that is telling us, that it just skipped over it. And it did, because why would I want to rerun it a second time when I know the first time it's not going to be safe? So why run it second time? So just trying to save some time running these simulations. But if you only want to see the ones that are recommended, again, come to the column header, right click on it, and then just choose show only recommended motors. And so then it deleted all the non-recommended, and it's only showing us the good ones. So any of these motors would be a good flight. So that is how you do recommended motors. How to pick motors really fast. It's basically, again, you go up here to prepare for launch, click on the recommend motors button, adjust your launch guide length. You know, if I make it 6 feet long, and then just say use recommended conditions, it's going to rerun them again. So it ran, the first time it ran 30 of them. Now it's running 27 of them. Remember I said that if I made the launch rod longer, it might think it's okay. Well, because of that, there are motors that are okay that were marginal or unsafe before. So that's why it's going to take a little bit longer this time. So it's always a good thing to make your launch rod as long as practical. So remember that B4? There it is. Now it's safe this time. And then the optimal delay is 4.32 seconds. And then it finds the recommended delay. The difference between the optimal delay and recommended delay, this is like perfect conditions. If everything worked exactly as we planned. The recommended motor is, okay, things don't work, never are perfect. So we're going to decrease the delay just down to the next whole number. So here we went from 4.32 seconds down to 4 seconds. Here we went 2.44 down to 2 seconds. This one, instead of rounding up, we always round down. So this one, you know, 6.98, that's like really close to 7.0 seconds. But we're going to round down to 6 seconds. So you would choose the Quest D16-6. So that's how that works. So if you have any questions on running recommended motors, it got so easy with RockSim. You know, it's almost like 2 button clicks. You click on prepare for launch, click recommended motors, and start. That fast. That's the advantage of having RockSim. Leon says, would you partnership with us in Bangladesh Space Research Society? You may search about us. It would be great to work with you. I don't know what partnership means. As long as I don't have to kick in any money or supplies or discounts, which is money, I'm all for it. I think you are already a partner. You just don't even know it, because a partnership means an exchange of something. And right now you're getting the better end of the deal because you're getting all of the good information that's on the Apogee website. You know, you're taking advantage of our huge catalog of information. And I put that out there for you as my part of the partnership. This is what I give to the partnership. Now, what are you giving in return? That's what I want to know. Okay, next question. Cord Michael says, having trouble getting you in DC. Ooh, what does that mean, having trouble getting us? Is the sound quality not okay? Or the video? I know the video sometimes lags with my mouth. And it's because the computer processor, it has to do the live streaming. So we're sending data out into the universe. And then we're also running software here on the computer. You know, I got a bunch of programs running. I not only have RockSim running, but I also have my live stream software running. And then I have YouTube running. So I got a lot of stuff that's going on. Carlos says, in RockSim, if a nose cone adds drag, does a tail cone subtract from it? And the answer is, let's find out. And we're going to answer the same question, Carlo. I'm going to answer another question that came in at the same time that's kind of related. Somebody asked, okay, I've got a rocket, and on some of the bigger rockets, you can buy a retainer. But the retainer is not your typical retainer. It's a tail cone retainer. So this is getting to Carlos's question, is a tail cone on the bottom, does it reduce drag? And And so the other question at the same time, we're going to say, how do you put on a tail cone retainer in RockSim? So this is killing two birds with one stone. Okay, so here we have a rocket and we want to put a tail cone retainer on it. So how do you do that? Well, if you come up here to the design components, you'll notice all these buttons, there's nothing that says retainer. Now there is a transition, and a transition is a change in diameter from one diameter to the other. So you can either have a small nose cone and a bigger body tube, or you can have a big nose cone, smaller body tube. And a transition is that nice smooth connector piece that makes that transition nice and smooth. And we can put a transition on the end of the rocket and call it a tail cone. So that's what we're going to do for the retainer. So we're going to add the retainer as a tail cone. So to do that, let me put this in 2D right now. So here we're looking at it in 2D. So that's this button right here. First I have to select what part I'm going to attach it to. So I'm going to attach it to this body tube. So I'm going to click on the body tube, and when I click on it, it highlights it here, and it also highlights it up here in the parts tree. So I'm going to click on it there to highlight, turn it blue. My color is set for blue. Your color on your computer may be a little different, but I'm just highlighting it. And now I'm going to click on the transition. You can see the transition button is activated, where the nose cone button is not. I can't add a nose cone to this tube, but I can add a transition. So I'm going to click on transition, and it's going to bring up a database. And now you could actually create a special part in your database called a retainer, and I can show you how to do that. It's really simple, but for right now it's not in there. So I'm going to cancel out of the database. And now I'm on the transition editor screen. So it's going to add the transition at the back end of the part that it was attached to. So here is the transition, and I can change these parameters here. So right now I'm going to go to the shoulder, because this is when I do a transition, I always want to know what the diameters are. So I'm going to go to the shoulder. And the shoulder is the part of the transition that will slide into the tube. So on a nose cone, here's the shoulder, and it slides into the tube. But one of the nice features of RockSim is you can use that to get the exact diameters for the transition. So, and we can do it by choosing the tube size. So I don't need to look at any dimensions here as long as I know what the name is of the tube. So the front shoulder, I'm going to choose a compatible tube, and I know that this rocket is a BT55 because I designed it. And your rocket, because you designed it, you should know what the tube is. And if you don't know, you can come right here. You can see here on the screen it says the diameter. This is the maximum diameter of the tube right now. And on this particular rocket, since it's all one diameter, I know that this diameter is this diameter. Now if you have other diameter tubes in here, it might not be that diameter, and then you'd have to figure it out. So now this tube I know is a BT55, which is 33 millimeters. So I know that this description is telling me it's 33 millimeters, and I'm going to click OK. And so what it did was it put a shoulder right here in the tube. All right. And now I'm going to do the same thing on the back end. Now, I don't know what this cone, what the actual diameter is, so I'm going to just guess right now. So I'm going to choose a compatible tube, and I'm going to say it's a 24 millimeter tube. So I'm going to click OK. And you can see it added another shoulder right there. Now I'm going to come back to this, but what I want to show you is I'm going to go back to the General tab here. And now I'm going to change the length, because I can't change the length right here. I can only change the diameters. But I'm going to change the length. I go back to the General tab. And then see right now the length is 0. And I'm going to grab the slider bar and click and drag here. But what you should do is watch down here as I drag. So I'm going to click and drag. You can see I'm making a transition. And if I look at it closely enough, for some reason, it's not exactly matching what I need. So I'm going to have to change that. But first, I want to just get the length right. So on a typical tail cone retainer, they're fairly short. I'm just guessing here. So I'm going to guess right here. And click OK. Before I do that, see it's got these shoulders on it? I want to clear those off. So that's why I said I'm going to go back to the shoulder tab. And now I'm going to clear those shoulders off of the part. So clear here, and you see they just went away. Now this, I want to adjust this outside diameter because it's just not getting out to the diameter correct. And so now I'm looking at this diameter 1.330 and going back to the general tab. And it says my front diameter is 1.18, so something's wrong there. It should be 1.33. So I'm just typing in 1.33 here, and then hit tab. And when I hit tab, watch. Look, I clicked on it, and it just jumped. It jumped from here back out to here. So now it looks like a real tail cone retainer. So now we need to specify the material. And typically, tail cone retainers are made out of aluminum. So I'm looking for aluminum as my material. And it's not going to be solid, because right now a solid aluminum piece weighs 38 grams. I'm going to make it hollow. And now you see, by making it hollow with a wall thickness of 0, it has 0 mass. I'm going to make, so now I adjust my wall thickness, and I'm going to keep adjusting it until I get the weight that I want, and I can see the weight of the part right here. So here I'm going to put 0.04, and you can see it jumped up to 5.7 grams. I don't know what this tail cone's going to weigh in real life, so I'm just going to leave it as that. And then I can set my colors over here. I'm just doing this because I want to make them pretty, or make it colorful or something. Let's make it that color blue. Okay, so now I have that tail cone. All these values are good. The shoulder values are cleared out. So we have a tail cone, and I'll click OK. Now, so that would be how to make a tail cone retainer. Now let's put it into our database so I can bring it up for other rocket kits. So I'm going to go back to this transition. I'm going to change the name. I'm going to call it tail cone retainer, if I can spell it right. Tail cone retainer. And I'm going to go to the database tab. I'm going to call it Tim's Company, even though, because this is a fictional part. I don't know when you're buying your parts. You can give it a part number, 1, 2, 3, whatever, and then a description. You could call it a tail cone retainer for BT 55, not 66 tubes. And then just come over here to save to database, or save to database. You can see it populated all the part manufacturer, the part number, and the part description right here. And then I can say save to database. And when it saves it to the database, it's going to be in your transition database. So click OK. So now it's in the database. So now if I actually go to the database, so I've added to the part there. So how do I confirm that it's there? So I can just, to confirm, I can just click on choose from database. And then I'll go through the manufacturer, and I'm looking for Tim's Company. So I'm scrolling down through it. and it should put it at the very bottom. Let's see if it's at the very bottom. So there it is. So here's my new tail cone retainer. So if I wanted to use this tail cone retainer in other rocket designs, it's in there. It's just you have to mentally remember where you put it. So click, I'm going to cancel right now because I was just confirming it that it's in there. So now it's saved into the database. Now, typically when you put in a rocket motor, that rocket motor is going to stop here right before the end of the tail cone. So now I'm going to adjust the position of the rocket engine. So to do that, again, we're going to go prepare for launch. Here's the rocket motor. I'm kind of moving it off to the side so that I can see this view right here, because I'm going to select this motor and I'm going to change the engine overhang. See, right now this motor is in this tube, this pink tube right here. And it overhangs that one by 0 inches. Now I'm going to kind of move it by looking at it to back here, but I don't know how far to make it. So like I'm just going to pick a number, right? Let's 4 inches, see what happens. So if you make it 4 inches, yeah, it's too far. Let's try 2 inches. And then hit tab. 2 inches, still too far. Let's try 1 inch. Yeah, still too far. Let's try 0.75 inches. Getting closer. Let's try 0.65 inches. Okay, so that's just inside. Let's make it 60. Hit tab. So now that motor is in there where I like it. And I'm going to yeah, let's run a simulation. So first let's say okay. We're going to set up the simulation. So now we're getting back to Carlos's other question. Does a boat tail or tail cone reduce the drag so your rocket flies higher? So how do we run that experiment? So we got a rocket motor loaded. So let's set up the launch conditions. So first I'm going to go to CD override, make sure that this is checked. We want RockSim to calculate it. So by checking it, RockSim calculates. If we uncheck it, it's going to use these values below. And then no matter what boat tail I put on, it's not going to change things because RockSim is not calculating it. It's just going to be a fixed number that you put in as the user. So make sure that this is checked. Now let's go to our launch conditions. So under simulation controls, leave that alone. Starting state, we're launching. Let's launch straight up. So I make it 0 degrees, hit tab. You can see now it's going to be pointed straight up. It's a 3 foot long launch rod, 36 inches. Launch conditions, I'm going to change the speed to wind speed to 0 wind, no wind, and it ignores all this stuff below. So once I do that. Okay, so now let's run the simulation. I'm going to just run the flight profile, just see what it looks like. Okay, so here's the rocket sitting on the pad, and we'll play the animation. Rocket takes off, and it's going up. You can see the altitude right over here. 480, something around 483. And if you want to get the exact value, click cancel, and it will be right here on the summary screen. Okay, so that's the simulation run with the boat tail on. Now, to make this an apples to apples comparison, we're going to delete the boat tail or the tail cone retainer, and we're going to rerun the simulation. But when I delete the boat tail, I'm also going to be deleting the weight of the boat tail. And now we have a lighter rocket. And which flies higher, a lighter rocket or a heavier rocket? So a lighter rocket's going to go higher. So, but now we don't have an apples to apples comparison anymore. So to make this work out, we need to add weight back into the rocket to account for the weight of the tail cone. So what was the weight of the tail cone? If I click on rocket design components, edit my tail cone retainer, it's 5.76 grams. So I'm going to delete the retainer, but I need to add back into the rocket 5.76 grams. And the location that I add it should be in the location where the current tail cone is, so that we don't move the center of gravity when we run the simulation. Okay, so 5.76, remember that. So here's the retainer, and I'm going to highlight it and hit delete. And it's going to say, do you really want to delete? And I'm going to say yes. Okay, so now it deleted that, but now we need to add back the 5.76 grams. So where are we going to add it? What part are we going to add it to? I'm going to add it to the body tube, highlight it, and then we're going to say we're going to put a mass object to reaccount for the weight. A mass object is a component, and it's just a single little tiny point, but it has mass. And you could use a mass object for anything. You know, you could actually use it for the tail cone retainer. Typically you'd use it for like clay nose weight or items inside the rocket that you don't have a definite shape of, like electronics inside your rocket. So I'm going to click on mass object. I'm going to cancel out of the database. It always looks in the database first unless you uncheck it right here. I always leave that checked because otherwise I can get confused. I'm thinking, hey, it should be looking in the database. So hit cancel there. And this mass, we're going to call this the tail cone retainer fake mass. And it was 5.76 grams. And the location of it was right here. So currently it's showing the location of this mass object right here. I'm going to take it and I'm going to slide it back using the slider bar, and I slid it back as far as I can, but it's not quite far enough back. To get it to go further back, we can type in a value. So I'm going to type in, let's actually make it 10 inches. That's probably too far. So 9.5 inches. Is that? I'll make it maybe about 5.35. Okay, so that is kind of where I estimate where the mass is of that tail cone retainer. And I'll go click OK. So now we've got the mass equal to the mass that it ran previously. So now all I'm going to do is just rerun the simulation. And we'll just click launch. Okay, so now, whoo! See what went wrong here? We expected this value to go higher, and it went down. That's interesting. Oh, I know. When RockSim calculates the coefficient of drag, it's based on the components it sees, and like we talked about previously, Carlos, when you add surface area, you also increase the coefficient of drag. That number should have gone up. It should have gone higher. Oh, wait, no. I'm thinking backwards. This one is without the tail cone. This one is with the tail cone. Because with the tail cone, it has less drag, it goes higher. So it did work like I thought. I was thinking on this second one, we added the tail cone, where on the second simulation, we actually took the tail cone off. So you can see by adding that tail cone, this is without it, this is with it. The rocket does go higher because it does have lower drag. It worked. I like it when it works. So hopefully that answers your question, Carlos. Fatbank says, where can suggestions be submitted for RockSim? Okay, that's a good question. if you go here to the Apogee website, now let me open up the Apogee website. Go to the contact form right here. It says contact form. Click on that. This will bring up a box where you can contact us. But on the send to email, click on this. This is actually a drop-down menu. So if you click here, you can see other options like RockSim general questions and support, including keys. So if you send it, if you choose that one, it comes right to me because this is the one that I answer personally. So then you just fill out your name, your email address, and you type in your message and do the CAPTCHA stupid thing because bots always want to spam us. That's why we have the CAPTCHA. And that will come to me, and then I will see your submissions. Pretty simple, right? Hey, there we are, says Johan. I'm looking for other questions. Robert Wilfred asks, are there any issues running RockSim on Windows 11? Okay, so if you go to, this is where we're going to check the system requirements for RockSim. So go to How To and Guides, come down here to Software, and then go here to System Requirements. And click on that. And you will see what the system requirements are for RockSim. So for Windows, it requires Windows 11. And these graphics cards, you will notice that we have not tested it yet on Windows 11. But here's the thing. Even though that I haven't tested it, you can test it for free just by downloading and installing the free trial version. And I'm confident that it works under Windows 11, but I can't say exactly for sure. But to download a free trial that you can test, and if it doesn't work, just delete it. No harm done. You'll find out within, a couple of minutes if it works for you or not. Go to How To and Guides. Again, come back down to Software. And then right here, RockSim 10 free trial. Just click on that, and this is where you download a free trial version. So we also haven't tested RockSim on the Macintosh on the latest version, which is Big Sur. And the reason is, like, we don't have that many computers. If you want to send us more money so we can test it on Windows 11, that way I can go out and buy a Windows 11 computer. I can test it. Okay, so hopefully that answers that question. Any other questions? I don't see anything else. So we've talked about today tail cone retainers and tail cones in general. We also talked about what we started at the beginning is how to get recommended motors. Simple things like that. That's one of the big advantages of RockSim. Fatbank says thanks. Okay, Johan says, okay, question on RockSim. I build a model with pods and it has a way to calculate delay on the main rocket. Okay, so he's got Robert Wilfred says his computer wants him to upgrade to Windows 11 and he's unsure if he should do it or not. I would hold off. I know it's annoying that it keeps popping up and says, we want you to upgrade so that we can track you better. I'm thinking about Johan's question here. Kevin's Models and More says, on your website, each rocket kit for sale has a list of recommended motors. Some show dozens and dozens of options. Do you use RockSim to calculate altitudes, or do you actually launch all those motors? We use RockSim, Kevin. Yes, we definitely use RockSim because You're saying dozens and dozens. You're not looking at the other kits. If you go to like high power motor kits, like the Katana, if I type in the Katana on our search, you click there, and then you go down to recommended motors. There are, I could scroll all day long here. There are hundreds of motors, and so those are the 54 millimeters. You can also put in 38 millimeter motors into that kit. So there's all the 38 millimeter motors. And yeah, so we use RockSim. The feature that I showed you on recommended motors, I made that feature for me so that I could do this, make these motor charts. That's exactly how we make them. I'm that confident in RockSim's ability to calculate the safety of a rocket that what it recommends, I'm okay with. So that's how we come up with those. Okay, Johan's question. I build a model with pods, and it has a way to low calculated delay on the main rocket. Aware of the problem? I am not aware of this, Johan. I was playing, let me show you something really cool. Because there was a bug in the RockSim launch visualizer. So if you go to rocksim.com, rocksim.com, we fixed the bugs with pods. And now the pod feature works, and it works really cool. And I wanted to show you what it looks like. So I'm going to go select the design. So you can do this yourself. Go to select the design, choose a design. There's demo designs, and then there's user designs. And I think one of the demo designs was the Apogee flying machine. So you can select that. And this is a rocket with pods on it. So once it loads here on the screen, and if I zoom in, you can see it has these two strap-on booster pods strapped onto the rocket. And so now we can launch this rocket. So first let me pick a launch site. Oh, I'm not logged in. So let me log in real quick. Come on. Where's my name? Come on. There we go. Okay, logging in. Am I still seeing the okay, I'm going to choose a launch site. I'll just choose this one here. Click OK. And it's going to redraw it on the map so I can see where it is. All these little thumbtacks are launch sites that are in the database. So this one's in the database for an actual NAR club. I'm spinning it around. I want to get north, kind of aimed up to the top, so we can get a kind of better perspective on where we're launching from. I'm going to pan out a little bit. See, this is in a parking lot, but I think there's a nice field here off to the side. Yeah, there's some nice green grass here. So to move the launch site from here to here, you just double click. You can see it put a dot right there. So that's where the pad is going to be if I hit this button that says confirm launch site. So I'm going to confirm that launch site. So now we're going to launch from that grass. And then we're going to, I got some nice grass down here to the southwest. So I'm going to aim the rocket that way. Oh, we went back to the Avion. That's what I was afraid of when we had to log in. See Sting, there it is, flying machine. Select that. Okay, so now you can see the launch rod is angled because I changed the launch angle, and as soon as it draws the rocket there. Okay, come on, draw the rocket. if it doesn't want to draw the rocket, refresh the browser. Just go up here to the refresh button. Come on. Is my internet slow? The problem with refreshing is I'm going to have to reload that rocket design. Choose design. Oh, I need demos of designs. What am I looking at? Demo designs. Flying machine. Select. Okay, so here's the rocket on the pad. Choose that different launch site again. That was site 1. I'm just going to leave it where it was. I'm not going to remove the pad. Launch angle. This time, because I'm in the parking lot, I'm going to launch more to the southeast and angle it that way. Okay, so here's where we're going to set up the pods. I think that's angled too far. Okay, so we got a 24 millimeter that's in the core. You see right next to my arrow right there, the red dot is in the middle of the rocket. That tells me it's in the core of the rocket. And these 18 millimeter motors, those are on the pods on the side. So this one says this is in a pod, this is in a pod, this is in the core. So when I say core, I'm talking about the main part of the tube right here. This is the core, these are the pods. So on the core engine, double click on that to open up the engine selector. And let's choose an Aerotech, I don't know, F15, E15. And then the ejection delay, no, that's ignition delay. Ejection delay is right here. Let's choose a 7. Come on, I missed it. 7 seconds, click OK. So that one's loaded, and then let's load these 2 engines in the pods. Choose an engine for that. Let's make one of them an A8-0. Click OK. And we'll make the other one in the other pod. Let's make it something bigger, like a C6. C6, instead of falling off at 3 seconds, let's 0 seconds, let's have it fall off at 3 seconds. Click OK. So in one of these pods, we have A8-3, no, -0, and the other one is a C6-3. And now we're going to deploy the parachute at maximum engine ejection delay. So these pods don't have any recovery devices in them. If they had recovery devices, they would show up right here. But since nothing is showing up, that tells me that there's no recovery devices. So they're just going to fall like a rock straight down as soon as they fall off the rocket. So let's run this simulation. You just come down here to the launch button, click on that, simulate. While it's doing that, I'm going to take a sip of water. Why is it black? If you're seeing black, that means you're underground. That's never a good thing, but it's going to go 46 seconds. It's either that or it's not loading the maps. Oh, where's my maps? Let's stop this and let's see why this is not finding the map. Choose launch site. Click OK. Come on. Load my maps. It doesn't like that map. Let's try a different launch site. It's either my internet connection is bad or something's going on. Because it was just loading the maps earlier. Let's try running the simulation again. Just simulate. I'm crossing my fingers, hopefully I got a map. I got no map. Well, shoot. I have no idea why that's not loading. So the rocket is right there. I don't know if you can see that tiny green dot. That's the rocket sitting on the pad. I've zoomed out so that I can see the trajectory. So we can still see the trajectory because it was working. Oh, look at that, that rocket went so high. I'm zooming out so I can see the trajectory. There it is. Okay, so the rocket at this point is coming down under parachute, and if I pause it, and if I click on Find the Rocket, it will center the rocket right in the middle of the screen, and if I click the plus button, so there is the main part of the rocket. But if you look over here onto the side, you won't see any of the pods because the pods fell off. See, there's no pods there. So, hey, look at that. I'm seeing sky now. But I don't know, I'm still underground. But where are the pods? The pods are right here. So here's one of them. So if I click and drag that to the middle, and if I zoom in there, I should see a pod laying on the ground. And there it is right there. That white line, that's the pod. Now the other pod, that was the C63. Now I'm zooming out. The other one should be, if it was an A8-0, and that one should be, you see this green line coming down here? So at the bottom of that green line right there should be another pod laying on the ground. It's too bad that the maps aren't showing up because that would be really cool. So try out the pods. Give it a try. Hopefully you won't have the black screen right here. We shouldn't be having black screen. But if I refresh, then it's going to unload my rocket in my simulations. Well, wait a minute. Let me try that one more time. Maybe there's something. If I open that back up, because it saved the simulation, because it's under my account. Select rocket design, choose design, demo design, and it was the flying machine. There's the flying machine. Click select. And now if I go here to the data, that last simulation would be what, remember I had an E15, an A80, and a C63. If I click that and hit rerun, maybe crossing my finger, I think because it loaded the Earth in the background there, it should load my maps. Yeah, now it's loading. See, it's changing color green, and it's going to be green because I'm in the grass there. No, remember I was in the parking lot. So that's the parking lot of this building here. This is at some school. So if I launch, so this time we should see the pods sitting on the ground and not in the black. Okay, so I'm going to pause it right there. And now here's one of them fell off there. Here's the other one that fell here. This one will probably be on the ground already. I'm clicking and dragging, trying to move the camera to point where I want it to point. There it is sitting on the ground, which is cool. So what I think I'll do is share this, and I'll put this in the chat, and then you can open this and play around with it. So I just put in a link in the chat. So if you open up that link, you will see exactly what I saw on my screen, except you won't, because you're not logged in, you won't see the trajectory lines. You'll see the parts laying on the ground, and you'll see the flight all the way from liftoff to touchdown. You just won't see these trajectory lines that kind of tell us, you know, that gives us information on where the position of the rocket is relative to the ground right there. So that's what you won't see. Now this link will be active for 30 days. So if today is the 28th of February, so by the 28th of, no, today's the 28th of January, 28th of February, that'll be the last day that this will be active, because it just automatically purges it from the database. But we keep it around. When you share a design or share a simulation like this, it stays in a buffer for 30 days so all your friends can see it. So take a look at that. It's fun. And you'll see the pods falling off. So hopefully, Johan, if you think there's a bug in RockSim, try that same design, upload it into the launch visualizer and run it there and see what happens. Because I'm pretty sure the launch visualizer is working fine. I can't confirm or deny a bug in RockSim because I don't know what you're talking about. So contact me through the Apogee contact form on our website. Remember our website? If you go to the website and click on contact form and then choose, you know, RockSim questions, and those will come right to me. You can't attach a file here, but once you email me, I can email you back, and then you can attach it to that email as you come back to me. Oh, we've gone way long. Johan says an A80 will burn out your tube. Yeah, I've used A80s just fine as booster motors for pods. It works fine. It's one of the recommended ones in the Flying Machine rocket that I was just playing with. If you're toasting yours, there's something different about your setup, and I don't know what it is. Johan also writes he got 850 likes by posting on this Facebook page. If you post on the Apogee page, you might get like 2 likes. One of them will be me. We don't get a lot of traffic to our Facebook page because we don't post there very often. It's just, we're a smaller company, and I have smaller, you know, we don't have the manpower that Estes does. So I do envy you for getting 850 likes. That's cool. All right, we're done. We've gone long again, as always. So I got to end the stream. So we will be back next Friday. And I'd like to say thank you to Michelle for covering for me last week when I was in Virginia. I was actually participating, like you, as a watcher. And I was in the chat. So she did a great job. Everything that she did was like spot on. I was going to try to give her some hints and tips, but she knew my hints and tips, so I didn't even have to do that. She was great. So until next week, go out and launch something. So in 5, 4, 3, 2, 1, launch.